Welcome to myprojectbazaar.com.
Now we are going to discuss about the product Predictive Data Mining for Medical Diagnosis and Overview of Heart Disease Prediction. Now we are going to discuss about the abstract for the process. The successful application of data mining in highly visible fields like e-business, marketing and the retail has led to its application in other industries and the sectors. Among these sectors, thus we can just discovering is healthcare. In the healthcare environmental is still information rich but knowledge poor. There is a wealth of data available within the healthcare systems. However, there is a lack of efficiency and the effective analysis tools to discover the hidden relationships and then trends in the data. This to provide a survey of current techniques of knowledge discovery in databases using data mining techniques that are in the today's medical research, particularly in heart disease predictions. Hence, we can apply in this paper. We can apply the efficient feature extraction and then the classification method to predict the heart diseases. Hence, to predict the heart diseases, we can apply this process in the signal processing. Just take the ECG signals from the data sets. After that, the feature is extracted from those signals. Then the classification is done by using the KNN classification to find whether the input signal is normal or the abnormal signal. So hence this is well applicable for the dataset signals, and this is gives the more efficiency as well as the more stability of the features. Hence this will be applicable for the all the data sets once we have to train. This is the overall flow diagram for the process. At first, the signal acquisition is done. Signal acquisition is nothing but the getting the input signal from the dataset. After getting the input signal from the dataset folder, the pre-processing is carried out. In this pre-processing module, the Butterworth filter is applied to remove the noises present in the signals. Butterworth is the type of filter which is used to remove the noises presented in the signal. After the pre-processing, the noise-free signal comes out from the pre-processing. After the noise-free extractions, the feature extraction is carried out by using the two methods, that is the peak and valley detection and then the RR interval. By using these two steps, we can extract some feature values, that is the feature points from the signal. After the extraction of the feature points, that is considered as an test feature. After extracting the test feature, the classification is done by using the KNN classifier. KNN is abbreviated as an K nearest neighbor. After the extraction, after the classification, the performance is estimated. Between that, we have to give the three things as an input for the classification. The first one is the test feature, then the second one is the train feature, and then the third one is the target. Test feature is the feature from the input image. Train feature is the feature from the overall dataset signals. Then the target is the target of the whether it is normal or abnormal. Hence we have the two targets. After the extraction of the features and then the classification, the performance is estimated by means of the three parameters, namely accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the code means just right click in the mainfile.m and select the option run. Now the dataset folder was opened. In this dataset you can see the 10 signals. Select any one signal from the dataset After that we have to enter the FSS value. The FS value is the 250. Now enter the 250 and give the enter button. Now the process will be done automatically. Now I will explain the result one by one. Now the figure 1 shows the input signal which I have selected from the dataset. After the selection of the input signal, the selected signal is shown in the figure 1 with the title input signal. After that, the filtered signal is shown in the figure 2 with the title filtered signal. Now in the filtering step we can apply the Butterworth filter. Now the range of the filter is the signal is the 0 to 4000. Now the filter signal are also in the range of 0 to 4000 in the x-axis. Now the filter, you can see the difference between the input and the filtered image. After that, the feature extraction is done. Now the figure 3 shows the feature extraction values. Now the feature extracted value is plotted in the graph format. Now the raw signal QRS, T wave and P wave is shown. The upper peaks are known as the peaks which have the peaks. Now the lower peaks are the peaks that is known as the valley. Now the peak and valley interaction, then the RR interval is calculated between these peaks are calculated, then those values are saved as an test feature values from the signal. Those test feature values are plotted in the table format. Now those values are shown here. Here we put the 30 values from the signal. After that the classification is done. In the classification step, the message box will be opened to display whether the input signal is normal or abnormal. Hence this signal is the normal signal. The message box will be displayed as a normal. After that, the performance is estimated by using the parameters like accuracy, sensitivity and specificity. Those values are plotted in the graph format, that is in the form of bar chart format. Now the accuracy value is approximately 90%. Now the sensitivity is 80%, specificity is 100%.